Okay, we're going to review the polynomial stuff a little bit. Just a quick, this is not meant to teach you, it's just a quick review. All right, so first of all, we want the roots of a polynomial. Those are the numbers that are going to make it equal to 0. So we know that if we get a polynomial in factored form, like 2x plus 3 times x plus 2 times x minus 8, the roots of this polynomial are going to be the x values that make that equal to 0. Okay, that make the entire thing equal to 0. So if I can get 0 in this chain, then I know that if I can get one of these links to be 0, I know that the whole thing's going to be 0. So let's see, if I can get this to be 0, then this and this doesn't matter what it is. Or if I can get this part of the chain to be 0, then that doesn't matter. And then if I can get this part of the chain to be equal to 0, I know that I'm going to get 0 out. So this is going to be equal to 0, equal to 0, equal to 0. So all of those. So P of what value is going to give me that? What inputs are going to give me those pieces? Well, over here, let's see. Now, if I want a 0 here, I'm going to need to, let's see, 2x plus 3 should be equal to 0. So 2x plus 3 should be equal to 0. So if I subtract the 3 and divide by 2, I'm going to get negative 3 halves. Okay, and then here, if I want this one to be 0, I need, let's see, x plus 2 equals 0, so x is equal to negative 2. And then what would it look like if this would be? What input would I have to put in to get that to be 0? That would be 8. Okay, so my roots are x equals negative 3 halves, x equals negative 2, and x equals 8. So those are the roots of that polynomial. Now we know that some roots, the real roots of a polynomial, show up as x-intercepts. So they will show up on the graph. Imaginary roots don't show up on the graph because the graph is just of all real numbers. So unless we do some fancy graphing, I guess. Okay, so let's look at now finding the roots. If we're given the polynomial in some kind of long form and we don't know what they are. Well, if it's a quadratic, we can always use a quadratic formula, or we can factor and we can get the roots of that. But what if it's something a little bit bigger? Well, first of all, I have to let me build this. Let's see, P of x is equal to, let's just do a little practice here real quick. Let's say 2x plus, 2x, the whole thing started falling down. 2x plus 5 times x minus 3 times x plus 1. So go ahead and pause the video right now and then come up with what the what this is if it was all multiplied up. Okay, so let's see. If you're still with me, I'm going to do this live real quick here. So these two together is going to give me 2x squared plus or minus 6x plus 5x minus 15. And then we're going to multiply by x plus 1. So that's going to give me 2x cubed minus 6x squared plus 5x squared minus 15x plus 2x squared minus 6x plus 5x minus 15. I didn't combine like terms. I'll just do that all at the end. So this is equal to 2x cubed, and then I have this 6x squared, so that's going to be this and this is negative 1. This is back to positive 1, plus x squared. This and this give me negative 21x, plus a 5x gives me negative 16x. Wait a minute. Yeah, that and that, negative 21, and that would be negative 16, that's right, and then minus 15. Okay, all right, so then I think I've got that. Those of you that maybe just came back from the pause or whatever, there's what I got, kind of flying without a net here. So we're gonna try that out. So I just needed, all we needed to do there was we just needed a quick review of how to multiply that out. Now, even though we know the answer to this, we're going to come up with, we're going to see if we can go backwards now, see if we can get back to that factored form so we can get the roots of the polynomial. So we know that P of x in standard form is 2x to the third plus x squared minus 16x minus 15. And if you remember, one of the factors when we came back, or go back kind of on the back side of it, one of the factors was x plus 1. So I know that x equals negative 1 is a root. So what if we're given a polynomial and we're given a root? How do we come up with the equation, or sorry, the rest of the roots? This is where synthetic division came in. So we put the root in the corner, and then we put the coefficients here. Thing that you have to remember with coefficients is that if this doesn't step down by 1 power every time, if it's missing a term, then you have to put a 0 in as a placeholder. Now remember, the key here is add down and then multiply by the box and put it up. Okay, so it's going to be add down 2, multiply by the box, -2, add down -1, multiply by the box, 1, add down -15, multiply by the box, 15, and then that's 0 there. So that's synthetic division. That was a quick way to do that. And now I know from my synthetic division, what I just figured out, if x minus 1 is a root, then I know that x plus 1 is one of the factors. P of x is the same as x plus 1. And then there's another factor down here. I just divided this out. So what's left over is the other factor. I got 0. That's the remainder. Remember, that's also the number that you'd get if you plug -1 into there. So that's the remainder. That's also P of -1. And that's kind of a nice thing that happens all the time. So this is now going to be 2x squared minus 1x minus 15. And I built that from the back. This is my constant term. This is my x term, so -15. This is my -1x's, and this is my 2x squared. So I build it from the back. It always goes constant x, x squared, x cubed, and so on. Okay. So now we know. Now we're down to, what's nice about this is one of our factors is now a quadratic. So once we have a quadratic, we know that even if it doesn't factor, we can still find the roots with the quadratic formula. And let's see, if I'm going to factor this, x plus 1 and let's see, it's going to be 2x and x, and I need the middle to be 1. So if I make this a 3 there and a 5 there, that's going to give me 6. That's really good, and that's going to give me 5, and that's what I want. I want one of them to be negative. So I guess I want the 6 to be negative. I want the 5 to be positive. So there are my 3 factors, and if you go back and rewind, I think that was how it factored before. So now I can say the roots, again, let's see, P of what's going to make this first one 0. And then P of something is going to make this second one 0. And then P of something is going to make this third one 0. And I guess this is going to be -1. This one's going to be -5/2, and this one's going to be 3. So the roots, x equals -5/2, x equals -1, and x equals 3. And those are all going to be x-intercepts in that case, because those are all going to actually produce 0. So there's your quick review on finding the roots of a polynomial.